Hello friends, welcome to the new lecture of network theory. So today we'll be discussing about the mesh analysis technique which is used in the to solve the network problems. So first let's discuss about the mesh. So mesh is a loop and that doesn't contain any inner loop. For example, in this circuit so many resistors are connected. So this is one loop, this is another loop, this is another loop, this is another loop, and these loops are not containing any inner loop, means these are the individual loops. So this is one mesh, this is another mesh, this is another mesh, this is another mesh. So four meshes are present in this circuit, and mesh analysis can be applied only for a planar network. What is a planar network? When the network is drawn on plane without any crossover, then the network is called as planar network. For example, this network. Here no crossover is present. So this network is called as planar network. Clear? Now let's see this network. In this network, here one crossover is present, this crossover. So this network is called as the non-planar network. Another planar network example is this network. See, you think that you can think that this is a crossover, but this is not a crossover. You can draw this network as like this, means draw this line to here. So this become as a this. So here no crossover is present. So this network is your planar network. So mesh analysis can be applied only for the planar network, and mesh is a loop that does not contain any inner loop. Clear? So what is the procedure for the mesh analysis? So procedure is that first you have to identify the total number of meshes present in your circuit, then assign the current direction for each mesh. After that, develop the Kvl equations for each mesh. Then by solving the Kvl equations, find the loop currents. So these are the procedure to apply the mesh analysis. For example, here one example I have taken. This example. In this example, two sources are present. One is a voltage source, another is current source, and three resistors are there. So let's say I am going to apply the mesh analysis and going to find the I1 and I2. So first step is your identify the total number of meshes. So here two meshes are there. One mesh is this one, because this is a one loop and this is another loop. So this is another mesh. After that, assign the current direction for each mesh. So here I have assigned like this, current direction I1. Here I have assigned like this. You can assign like this also. Then develop the Kvl equation. So now I am going to write the Kvl equation for this loop and for this loop also. Clear? So Kvl equation, let's say I am writing for this loop. So here this 4-volt battery is there, and the minus sign is there. So by sign conventional, this will be plus 4. Now I am moving in the direction of the current. So by sign convention, minus I am taking. What is the voltage drop here? I1 into 1. So I1. Clear? Now I came here. Here one current is your I1, another current is your I2. Clear? Here I1 current is like this and I2 current is like this. So total current will be your I1 minus I2 if you are moving like this in the direction of I1. So in Kvl equation you are moving in the direction of I1, in the direction of current, so minus sign. So drop will be 2 into total current. So total current is I1 minus I2. 2 into I1 minus I2 equal to 0. So this is the Kvl equation for this loop. Now similarly write the Kvl equation for this loop. So for this loop you can write see here no voltage drops are there. So if no voltage drops are there, so you can write the Kvl equation for the, and 2 ampere current is flowing here. So 4. So this become as 4. Let's say solve this equation first. 4 minus I1 minus 2 I1 plus 2 I2 equal to 0. Clear? Now this become as 4 minus 3 I1 plus 2 I2 equal to 0. So this is equation 1. Now again write the KVL equation for this loop. See here, for this loop I2 current is there and one current source is also there. Means the I2 is same as the magnitude of this current source, but this current source is having a direction of like this, and your I2, whatever you have assumed, that direction is like this, means both the direction are opposite. So I2 will be your minus of 2 ampere. Clear? Now put the I2 equal to minus 2 in this equation, you will get the I1. So I1 you are getting as a 0. So this is how to apply the mesh analysis. Clear? So now how many number of equations will be present for writing the mesh equations, mesh analysis? So total number of equations will be your total number of meshes. Whatever number of meshes or loops will be there, individual loops, those many number of equations you need to write, and those many number of equations you need to solve. Means equation equal to total number of meshes. So here 2 meshes were there, so 2 equations. Clear? Also equation equal to b minus n minus 1. This also you can apply the formula. What is b here? B is your total number of branches and n is the total number of nodes, that is principal node. Clear? Means how many branches are there? One branch is this one branch is this, and another branch is this. So there are 3 branches, so 3 minus how many nodes are there? This node, and this is a common node, means this and this node and this node. Clear? So 2 nodes are there. So 3 minus this equal to 2, means equation is coming as 2. So this formula also you can apply for finding the number of equations, and also this means total number of equations should be equal to total number of meshes. Clear? So this was about the mesh analysis. Let's solve some questions on the based on the mesh analysis. For example, this question I have taken here. In this question you need to find the value of I for the circuit shown. So here 5 volt battery is connected with 2 ohm resistor, and here also 2 ohm resistor, 1 ohm resistor, 3 ohm resistor, and one dependent source, and this dependent source is depending on the voltage across here, these 2 points, and the voltage across these 2 points is VAB, it is given, and the current is given as I. So you have to find the value of this current. Clear? So let's say apply the mesh analysis. So for mesh analysis you need to first identify the loop. So this is one loop, this is another loop, and this is also one loop, closed loop. Clear? Now apply the KVL equations. So for let's say I am applying the KVL equation here. So here let's say the voltage present across this 1 ohm resistor is V dash, let's say V dash. Clear? So apply so V dash will be your what? V dash will be your voltage drop across the 1 ohm resistor. What is the voltage drop across 1 ohm resistor? Current flowing through this 1 ohm resistor and the resistance value. So I is the voltage drop across this resistor. Clear? Now what will be the I value? I value will be what? If you apply the KVL equation here, then I value will be your total, apply the KVL here. So what is the total drop across this loop? 4AB. And what is the total resistance? 3 and 1. So 4 ohm resistor. So I will be your 4 VAB if you are applying the KVL in this loop, divide by 3 plus 1. Clear? Means VAB. So I is coming as VAB. So V dash is also your VAB. Clear? Now you need to find the VAB, then only you can find the I. This is your motive. This was the question, to find the value of I, but I is your VAB. So now you need to find the VAB. How to find the VAB? Here we have applied the KVL. Now you applied the KVL here. Clear? So let's say I am applying the KVL here. Let's say the current is I dash. Clear? So 5 minus of 2I dash minus of 2I dash equal to 0. So 5 equal to 4I dash. So I dash I am getting as 5 divided by 4 equal to 1.25. 1.25 or 1.25. Okay. Now if current is I dash is 1.25, then what will be the voltage, this voltage across this 2 ohm resistor? So voltage will be your 2 into I dash. So 2 into 1.25 equal to 2.5 volt. So 2.5 volt is the voltage across the 2 ohm resistor. And how this polarity I have taken plus minus, because this 2 ohm resistor is acting as a load, so current will always enter through the plus sign. Current is entering like this, that's why I have taken this plus and this as minus. So now I got the voltage across the 2 ohm resistor, that is 2.5. Now I apply the KVL to this loop. This drop plus this drop plus this drop. Clear? So apply KVL here. So let's say apply KVL in this loop. So let's say I am moving like this. So plus is coming. So minus 2.5. Then I came here. Minus is coming. So this will become as a plus V dash. Again minus is coming. So this will also become as VAB equal to 0. How much V dash? V dash is nothing but a VAB only. So minus 2.5 plus VAB equal to 0. So VAB I got as 1.25. Clear? And what is the I value? I is only the VAB. So I equal to 1.25 ampere. This is how you have to apply the mesh analysis and find the current value. Just identify the number of meshes, means individual loops. Then apply the KVL and find the current value. Clear? Next, let's solve this question. So in this question, one voltage source, two voltage source and one current source is given and two resistors. In this question you need to find the value of I1 and I2 for this current direction is also given and the I1 and I2 also given. So here you have to identify the loops. One loop is this one, another loop is this one. But here, see here you can't apply the KVL directly because voltage across this 2 ampere current source is unknown. You are not knowing the voltage. So you cannot apply the KVL here in individual meshes. So for these types of questions, you need to use the super mesh technique. What is that super mesh technique? In mesh technique, you are using the KVL and Ohm's law. In super mesh technique, you have to use the KVL plus KCL and the Ohm's law. Means KCL also you need to apply here. So let's say by KCL, here this by KCL, the I2 is like this, means I2 direction is upward direction, I1 direction is downward direction, and the current source direction is also upward. So by KCL you can write I2 minus I1 equal to 2. This is by KCL you are getting. Now apply the KVL. So for super mesh technique you have to apply like this. You need to take the loop like this, full loop. Clear? So using super mesh technique, I am applying the KVL in this full loop. So here this will become as a 2, this minus I1, I am going in the direction of the current, then minus I2, then minus 1 equal to 0. This is by KVL. Clear? So now solve these two equations, two unknowns, two equations I1 and I2. By solving you will get the I1 equal to minus 0.5 and I2 as 1.5. So here I have applied the super mesh technique. So when you have to apply the super mesh technique, when the current source branch is common for the two meshes, so it is easy to get the solution by using super mesh technique. Clear? This current source branch is common for the two meshes. So if you are getting like this, then you have to use the super mesh technique, means full one loop you need to take, and you have to apply the KCL and KVL both. So one note you make in note it down that mesh analysis, in mesh analysis you have to use the KVL plus Ohm's law, and in super mesh technique you need to use the KVL, KCL and the Ohm's law. Clear? So wherever you are finding the current source branch, you have to use the super mesh technique. If one current source branch you are getting, so one super mesh will be there. If more than one current source will be there, so you have to write the more than one super mesh equations. Clear? So this was about the today's class. Next class will discuss the nodal analysis, another technique for solving the questions of network theory. So thank you for the today's class.